Okay. Bismillahirrahmanirrahim. Welcome to the virtual remedial classes of 2025. On behalf of Mewa, I welcome you all to this class of physics, which is usually on Thursday. Uh, Projectile motion. So, as you can see here, we have a cannonball. You can see this black cannonball, risasi ya mzinga, na hii mzinga imewekwa mahali above the ground. There is some height from the place where hii bunduki imewekwa to the ground. It is at a specific height above the ground, iko juu ya ardhi kabisa. So projectile motion is whereby this thing hapa inatoka from this thing at an initial velocity. Sasa tutakuja kuona definition yake. So what happens ni kwamba kuna downward motion inatokea na kuna forward motion inatokea at the same time. Hizi motion mbili zote zinatokea at the same time. So hii kitu ita end up kufollow this path from this point to B. So that is what is known as projectile motion. As here definition yake inasema this is a type of motion that moves both forward and downwards. Sasa any type of motion whereby umekaa juu ya building tuseme. Wewe ni huyo uko juu ya building. Sasa then umerusha kama ni jiwe from that building. What will happen to that stone? Hiyo stone ita follow a curved motion. Sasa haitoenda ati straight wala haitoenda ati chini direct. Ita follow some curved path. Hii curved path ambayo tunaonyesha hapa. So hiyo motion whereby something goes both forward and downwards, kitu inaenda both forward and downwards, hiyo ndio inaitwa projectile motion. Sasa so yeah, there's that example kwamba when a person throws a rock from the top of a cliff, the rock will move a horizontal distance from the cliff. Hii rock first of all itaenda hivi. Sasa ita move away from the cliff a specific distance, which we learn how to calculate that distance, and that's while at the same time falling from the top of the cliff to the bottom. Hiyo rock ilikuwa hapa, at the end of the motion it will end up somewhere hapa chini. Sasa so there is a specific distance that rock will cover from where it was to the bottom of the cliff. Na pia hiyo rock ina move from juu kwenda chini. So there are two types of motion happening at the same time. Then there is one very important thing hapa. Imeandikwa kwamba this motion is assisted by gravity. It is not against gravity. Because kumbuka, this thing moves from top to bottom. Now gravity makes things to fall down. Sasa, so this motion inasaidiwa na gravity. So zile formula za free fall sometimes huwa zinatumika hapa katika projectile motion. They are mainly used in this type of motion. Sasa hapa hii kitu ambayo inaitwa u is simply ile initial velocity ambayo uliitumia kuirusha hii object. Maana ukirusha kitu chochote una apply some energy to it. So apply some energy to it, huwa kuna kuanga na initial velocity. The velocity where that object will leave from you. Hiyo ndio initial velocity. Sasa so sasa yeah, there's something that I've forgotten hapa. The horizontal motion, usually it uses the initial velocity to find the range. So let's say this is the diagram. So this is the diagram of the motion, how the motion happened. So there is this range from here up to here, range. So when the object moves from here and it is thrown up to until it lands on the ground, the initial velocity times time will give you the range. Velocity times time will give you the range. So in this motion, initial velocity is used during in the horizontal motion, not in the vertical motion. In the vertical motion, we assume that it fell without an initial velocity. Ile velocity ilitumika kwa horizontal motion peke yake, haitumii kwa vertical motion. Sawa. So there's an example of a question hapa kwamba a boy threw a stone from the top of a cliff that was 20 meters high. If the stone was found 60 meters away from the cliff, what was the time taken for the stone to land on the ground? So that is the first question. Sasa hapa you can draw this diagram of this situation. This is the cliff. Uh, this is the ground on the bottom. And this is the path of the stone. Yeah, the path of the stone. It went from up there, it landed somewhere here. So from here up to here, it is the range R, range which is equals to UT. Yeah, that is the range. And from here up to here, this is the height. The height which is equals to a half GT squared. A half GT squared. So the first question was the time taken for the stone to land on the ground. So can we guess which formula we use here? Of course, we'll use the first formula because we cannot use this second formula because we do not have u. We do not have the initial velocity. So we cannot use the second formula. So hapa tumeambiwa kwamba the height of the cliff was 20 meters. 20 meters is height. Sasa yamaanisha tunaweza substitute hapa tukasema since height is equals to a half gt squared, that means that height was 20 meters. 20 meters. So 20 meters will be equal to a half times gravity, which gravity is always 10. The gravitational constant is always 10 times t squared times t squared. Yeah. So first of all, we can just multiply a half and 10. So a half times 10 is 5. So 20 is equals to 5t squared. 5t squared. So divide by 5 on this side, and on that side also we divide by 5. So that to so that t squared ibaki peke yake. So by 5 inabaki ya t squared. Na 20 divided by 5 is 4. So 4 is equals to t squared. 4 is equal to t squared. T will be the square root of 4. The square root of 4 and the square root of t squared. So t will be 2 seconds. 2 seconds. So that is the answer of part A. That the time taken for the object to move from up here to down here is 2 seconds. That is the time taken. And we want to make one thing clear. The time taken for both the motions is the same. There's no difference in time. So, number B, question number B is saying that the initial velocity of the stone. So, we remember that R is equals to UT, initial velocity times time. We all know that velocity times time gives you distance. So, UT, but we don't have U, but we have R, because we are told that the stone was found 60 meters away from the cliff. That means the distance between here, down here, and where the stone landed was 60 meters. Ilienda mbali kidogo. 60 meters. So that means 60 will be equals to U times time, which time is 2 seconds. So divide by 2, divide by 2. We substitute 2 and we divide 60 divided by 2, which will be 30. So U will be equals to 30 meters per second. Yeah, that is all. Thank you very much for listening to me, and may God bless you. Thank you.